Hello, this is Dr. Liu. Before I discuss kinematics, I'd like to discuss the notations, which means how I use my symbols. So, for example, positions. And in most text, positions are x's. But since objects are moving, there are different positions at different times. So to describe different positions, we have these different notations. One way to say it is here x sub f, that's a final. X sub I, that's initial. So the change of position, which I use delta x, will be something like x final minus x initial. And this notation has its appeal because the final initial makes it clear what it is, right? And other times, the initial is written as x0. The 0 is the initial, and this x final stays as x final. So you could have something that reads x delta x is x final minus x0. The 0 always means initial in this type of notation. And yet another type of notation, the subscripts are all numbers, so you can have x1, x2, x3, x4, and so on. So your change in position could be calculated between any pair of positions, such as between 2 and 3, or even between 1 and 3, or maybe 3 and 4. So I could say x2 minus x1. Alright. Or there could be also displacement x4 minus x2, or so on and so forth. So I normally use this type of notation because it doesn't give a particular role, the final position, initial position, to any positions. These are just indicating that they happened over a sequence of time. x1 happened before x2, x2 before x3, x3 before x4. It doesn't make any assumption of how long the time duration was between the points, but it makes an assumption of the sequence of the positions showing was the same as the subscripts. So it's a little easier to understand. For time, basically the same. We use t, so t final and t initial, and sometimes t final and t0 for initial, or the series of t1, t2, t3, t4, and so on. So the change in time, delta t, will be t final minus t initial, or maybe written as t final minus t0, or written as any of these differences between them, say t3 minus t1, or maybe t4 minus t3, so on and so forth. So as long as you understand these are all mean the same, they have one of the times is a final time, the other one is an initial time, and make sure the right sequence is followed. The final time is greater than the initial time. So that's for time. And for say if you define velocity, so if you define velocity here, there could be the same exact type of notation differences: v final, v initial, v final, v0, or maybe this time I'll just pick two of them. So v2 and maybe v1. And the definition of v could be using the final initial, x final minus x initial, or t final minus t initial. That's one way to say it. Another way to say it is V is x final minus x0, that's also standing for initial, t final minus t0, or you can say V is x2 minus x1 over t2 minus t1. I prefer the numbered subscripts because it's more flexible. I can say well, x3 minus x1 over t3 minus t1, and I'll be calculating the average velocity between time 1 and time 3, right? So that is for velocity. Same thing for acceleration. So there could be acceleration final, acceleration initial, v final, acceleration final, acceleration 0 for initial. I keep saying v. So a2, a1, as such. So you can define acceleration as v final minus v initial, or t final minus t initial, or maybe a is v final minus v 0, sometimes also written as or read as naught, so t final minus t naught, or using the numbered v2 minus v1 or t2 minus t1. This is what I'm more used to. I'll be using this notation, although all the other notations are just as valid.